In this episode, we focus on a reality that surprises many new learners. A system's security is often shaped as much by other organizations as it is by your own technical choices. Modern environments rely on partners, vendors, cloud providers, contractors, and outsourced services, and every one of those relationships introduces obligations that must be handled deliberately. When you hear third-party risk, it can sound like a separate governance topic, but for security architecture it becomes very concrete, because you must design boundaries, access, monitoring, and evidence flows around what outsiders can do and what you must prove they did. Contracts are not just legal paperwork, because they contain requirements about confidentiality, service availability, incident notification, data handling, and audit rights that become architecture constraints. If you ignore those obligations until late in a project, you often end up patching the design in uncomfortable ways, such as bolting on monitoring or restricting access after the fact. By learning how to design with third-party obligations in mind from the start, you reduce friction, protect sensitive data, and build systems that remain trustworthy even when pieces are operated by someone else. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. To begin, it helps to define what third-party and outsourcing mean in an architecture context, because the word third-party can refer to many different relationships. A third party can be a vendor providing software, a managed service provider operating infrastructure, a partner connecting to your network for shared workflows, or a contractor with privileged access for maintenance. Outsourcing can mean handing over an entire function, like monitoring or support, or it can mean using a specialized external team for a narrow task. The key is that control is shared, meaning your organization is accountable for outcomes even when another entity performs actions. This shared control creates a need for clarity about responsibilities, because security gaps often come from assumptions like they handle that, or we assumed you did. Architecture work must make these boundaries explicit in the design and in the supporting agreements so the system does not depend on wishful thinking. Contractual obligations usually cluster around a few common themes, and those themes can be translated into architecture questions that guide design. One theme is confidentiality, meaning how data is protected from unauthorized access by the vendor's staff, and other customers in shared environments. Another theme is integrity, meaning how you prevent unauthorized changes and how you detect and correct changes that do occur. Availability is also common, meaning what service levels are expected and what happens when a provider fails or experiences disruption. Incident response and notification obligations are often present, defining how quickly the provider must notify you of issues and what information they must provide. Finally, audit and evidence rights may appear, meaning your ability to review controls, receive reports, or perform assessments. When you view contracts through these themes, it becomes easier to see how they shape architecture decisions like segmentation, encryption, logging, and recovery planning. One of the most important architecture moves for third-party relationships is to design clear trust boundaries, because a boundary defines where your control ends and where assumptions must change. A trust boundary is not just a network wall. It is any point where identity, data, or control crosses into a different administrative domain. When you cross a boundary, you should assume different security controls, different incentives, and different visibility. Architecture uses boundaries to limit blast radius, meaning the impact of a failure or compromise, and to ensure that high-trust areas are not casually exposed to lower-trust areas. For example, if a vendor needs access to a subsystem, the design should isolate that access to the smallest necessary scope instead of giving broad access to the whole environment. Boundaries also help with compliance and evidence, because they define what monitoring and logging is necessary to prove obligations are being met. In exam scenarios, the best answers often involve creating strong boundaries and minimizing trust rather than expanding access for convenience. Identity and access control is another major area where third-party obligations become architectural, because most outsourcing relationships involve some form of access. The architect must ensure that third-party access is specific, limited, and accountable, which means access should be granted based on role and need, not on organizational status. Privileged access deserves special attention because it can bypass many normal controls, so the design should include constraints like strong authentication, session accountability, and separation of duties where feasible. Another architectural principle is to avoid shared accounts and to ensure individual identity can be traced, because accountability depends on being able to attribute actions to specific people or processes. Access should also be time-bound and reviewed, since vendor needs often change over time and forgotten access becomes a risk. Even though we are not discussing tools, the concept is simple. Design the system so that outside access is controlled like a high-risk operation with clear evidence trails. Contracts often require that access be limited, and architecture must make that limitation real rather than a policy statement. Data handling obligations often require careful thought about where data lives, who can see it, and how it moves, especially when a vendor processes or stores sensitive data. A contract might require encryption, separation of customer data, or restrictions on subcontractors, and those requirements influence how you design storage, processing, and data flows. A common misconception is that once data is encrypted, the problem is solved, but in many systems the vendor's service must decrypt data to process it, so confidentiality still depends on access controls and operational practices. Architecture can help by minimizing what data is shared, limiting sensitive fields, or using tokenization or other approaches that reduce exposure while still enabling the business function. You also want clear retention and deletion rules, because many contracts and privacy obligations require that data not be kept longer than necessary or that it be deleted when the relationship ends. If the architecture does not support these lifecycle controls, the organization may be out of compliance even if the system seems secure. The best designs treat data sharing as a privilege that must be justified and controlled. Monitoring and logging are essential in third-party scenarios because you are responsible for outcomes, but you may not have direct visibility inside the vendor's environment. Contracts often try to close this gap by requiring reports, attestations, or audit support, but architecture can also help by instrumenting what you can see at your own boundaries. For example, you can log access attempts, data transfers, and administrative actions that occur through your controlled interfaces. You can also design for alerting on unusual behavior, such as access outside expected hours or unexpected data movement patterns. The key is to design evidence flows that give you enough information to detect problems and to demonstrate compliance without needing to inspect every internal detail of the vendor's systems. This is an important exam concept because it shows that an architect thinks about verifiability, not just theoretical security. When you cannot directly control something, you either contract for evidence or design for observable signals, and often you need both. Incident response obligations are another place where contracts and architecture meet, because an incident involving a third party can create delays and confusion if roles and data are not defined. Many contracts include notification requirements, such as time windows and required content, but architecture influences whether you can actually meet your own responsibilities. If you cannot determine which data was affected, you cannot respond properly, and if your logs do not capture third-party actions, your investigation will stall. Architecture can improve readiness by ensuring clear integration points, consistent logging, and well-defined data ownership. It can also help by designing for containment, such as being able to disable third-party access quickly without breaking the entire system. If a provider is compromised, you may need to isolate interfaces, rotate credentials, or shift to a fallback process, and those actions depend on design choices made earlier. Exam questions often test whether you anticipate the need for containment and evidence when third parties are involved. Another common area of contractual obligation is service reliability, including performance and availability, which can create security impacts when services degrade. If a vendor's service fails, teams might bypass controls to keep operations running, such as moving data through unapproved channels or disabling checks that feel like obstacles. Architecture should plan for failure modes so that security does not collapse under pressure. This may involve defining acceptable fallback behaviors, ensuring critical functions degrade safely, and maintaining essential logging and access controls during outages. It also means designing integration in a way that limits dependency on a single provider for high-impact workflows, or at least acknowledging the dependency and building compensating controls. Contracts often include service-level expectations, but those expectations are not magic because outages still happen. The architect's responsibility is to ensure the system stays as secure as possible when reality differs from contract language. Subcontractors and fourth parties add another layer, because your vendor may rely on other vendors, and those relationships can extend your risk in ways you do not immediately see. Contracts may include requirements about approval of subcontractors, notification of changes, or restrictions on where data can be processed. Architecture must account for this by keeping data sharing minimal and by ensuring that critical security requirements are enforceable regardless of who touches the data. For example, if a vendor changes where data is stored or who processes it, that can affect jurisdictional obligations, privacy expectations, and incident response capabilities. Even if you do not manage the subcontractors directly, you are still accountable for the outcomes, so the architecture should not depend on hidden assumptions about who is in the chain. A good mental model is that every additional party increases complexity, so your design should reduce the need for trust and increase the ability to verify behavior. A practical way to handle third-party obligations is to build an internal standard set for third-party integration, so teams do not reinvent the rules for every relationship. This can include requirements for identity, access scope, logging, data handling, encryption expectations, and termination procedures when the relationship ends. The goal is consistency, because consistency reduces gaps, speeds onboarding, and improves audit readiness. It also gives procurement and legal teams a technical foundation for contract language, since they can reference internal standards rather than negotiating from scratch each time. For beginners, the key takeaway is that architecture and contracts should reinforce each other, not exist in separate worlds. The contract sets expectations and rights, and the architecture makes those expectations measurable and enforceable. When these align, you avoid the common situation where a contract promises something that the design cannot prove. Exam scenarios often ask for the best architectural approach when integrating with a partner or outsourcing a function, and the best answers usually share a few characteristics. They minimize trust and privilege, define clear boundaries, and ensure accountability through traceable identity and logs. They consider data lifecycle, including retention and deletion, and they include plans for incidents and failures so security does not collapse under stress. They also reflect the reality that you need both contractual controls, like audit rights and notification requirements, and technical controls, like segmentation and monitoring, to manage shared responsibility. If an answer focuses only on contract language without technical enforceability, it is often incomplete, and if it focuses only on technical controls without recognizing contractual obligations, it often misses governance realities. The architect's job is to connect the two so the system works and the organization can defend its decisions. To conclude, designing for third-party and contractual obligations is the discipline of building systems that remain secure when parts of the work and control are shared across organizational boundaries. You start by understanding the relationship type and the obligations that come with it. Then you translate those obligations into enforceable design constraints around boundaries, access control, and data handling. You design for visibility and evidence, because accountability requires proof, and you plan for incidents and failures because contracts do not prevent disruptions. You also account for subcontractor chains and the reality that trust can expand silently if you do not constrain it intentionally. When architecture and contract expectations align, integration becomes smoother, audits become less painful, and the system is more resilient to real-world surprises. That is the mindset the exam is looking for, and it is a core skill for any security architect working in a partner-driven world.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.